Hello everyone, welcome to Digital Communication Tutorials. In this video, I am going to take up the first numerical on digital modulation techniques. Please note, this is a numerical on drawing the modulated signals. Let me read out the question first. For the given binary sequence B equals 10110, plot the modulated signal using the appropriate signal representation. Then we have part A, B, C representing ASK, PSK and FSK respectively. Let us start with the solution part and I will start with ASK here. For ASK system, we start by saying the appropriate form of binary data representation for ASK is unipolar signaling, where as is given in the equation for symbol 1 here, S1 of t is equal to square root of 2 EB by TB into cos 2 pi FCT, and symbol 0 is represented as S2 of t equal to 0. Please note, this is also called as on-off signaling scheme. For unipolar representation, we have given symbol 1 and symbol 0 representing S1 of t and S2 of t respectively. Let us now start plotting the waveforms. I am going to start with the x-axis here, which is the time axis, and y-axis represents the amplitude of the modulated signal. Please note, the waveform we are plotting is the modulated signal. I am going to then divide the x-axis into time divisions. Since we are given 5 bits, I will start with a 0 here, then I have TB, 2 TB, 3 TB, 4 TB and 5 TB. Please note, this is 5 TB. After that, I am going to write down the given binary sequence in each bit interval. Starting with, we have a 1, then we have a 0, then again we have 1, then 1 again and lastly 0. Let us talk about the first bit now. The first bit is 1. So, we come back to the equations for symbol 1. Symbol 1 is represented by S1 of t and S1 of t is given as square root of 2 EB by TB cos 2 pi FCT. So, in simple words, I am supposed to now transmit the carrier signal with a given amplitude given by square root of 2 EB by TB. Now, that is what is shown here for the first bit interval. You see, I am starting with the cos signal here and I have shown the same for 2 cycles. I have assumed that over 1 bit interval, there will be 2 cycles of the carrier wave being transmitted. So, whenever bit 1 appears, you transmit the carrier signal with a finite amplitude, and whenever 0 appears across the input, as per the equation for S2 of t, we transmit nothing. In simple words, whenever a bit 0 appears across the input, the transmitter is completely turned off. That is why we call this signaling scheme as on-off signaling scheme. Right, that is the idea behind ASK. So, whenever bit 1 appears, all you need to do is to plot the carrier signal for a finite number of cycles, and whenever bit 0 appears, you turn off the transmitter. Therefore, nothing is transmitted for that bit interval. If you continue using this concept, then for the given binary sequence, you will be very easily able to plot the modulated signal waveform, which is what is shown here. Right, that is about ASK. Let us now move on to the second part of the question, that is for PSK. Now, the most important thing about PSK is, for PSK, the appropriate form of binary data representation is polar signaling. Please note, for ASK it was unipolar or on-off signaling, whereas for PSK it is polar signaling scheme. Here in PSK, symbol 1 is represented by the signal S1 of t given by square root of 2 EB by TB cos 2 pi FCT, whereas symbol 0 is represented by S2 of t, which is given by square root of 2 EB by TB cos 2 pi FCT plus pi. That is, when symbol 1 is transmitted, we transmit the carrier signal as it is, whereas whenever symbol 0 needs to be transmitted, we phase advance the carrier by 180 degree and then we transmit the same. So, whenever a 1 appears, I would simply transmit the carrier, and whenever symbol 0 appears, I will invert the carrier and transmit the inverted one. That is what I have shown in the diagram that is given here. Let me once again start the diagram. You start with the x-axis, which is the time axis. Then you divide the x-axis into 5-bit intervals. The y-axis represents the modulated signal. Then over each bit interval, you mark what is the corresponding binary bit. Here it is 10110. The first bit here is a bit 1. So, for symbol 1, we say S1 of t given by square root of 2 EB by TB into cos 2 pi FCT should be transmitted. So, it is a carrier signal of a finite energy, that is it. So, you transmit the corresponding cosine wave, let us say for 2 cycles, that is what I have done here. Then, when symbol 0 appears, which is our next bit, I have to now phase advance the carrier by 180 degree. So, if you look at this corresponding portion, that is the transition from bit 1 to bit 0, you will see there is a phase change of 180 degree. That is what happens when there is a change from bit 1 to bit 0 or from bit 0 to bit 1. Since this is binary PSK, every time the data changes from either a 1 to 0 or a 0 to 1, the phase changes by a value of 180 degree. On the other hand, when there is no change, for example, in the case that we have shown here, we have 2 consecutive bit 1s appearing. So, in such a case, the phase continuity will be kept and there will not be any change in the carrier phase. So, for bit 1, we transmit the carrier, and for bit 0, we transmit the carrier, but after phase advancing it by a value of 180 degree. When you use this concept and plot the waveform for the given binary sequence, you would have plotted the binary PSK modulated signal. Right. Let me now move on to the last part of the question, that is for FSK. Now, for FSK, the appropriate form of the binary data is once again unipolar. Please note, both ASK and FSK use unipolar signaling schemes, whereas PSK uses polar signaling scheme. Let us now see how symbol 1 and symbol 0 are represented for FSK. Since it is frequency shift keying, you would require 2 completely different carriers for transmitting each of the input bit. For example, as you can see here, for bit 1 or symbol 1, we have S1 of t given by square root of 2 EB by TB cos 2 pi F1 t. Please note F1 here indicates frequency 1. And for symbol 0, S2 of t is given by square root of 2 EB by TB cos 2 pi F2 t. So, here F1 and F2 are not equal to one another. That is the most important thing. Right. So, for this particular case, what I have done is I have assumed F2 is greater than F1. That is, symbol 0 is represented by a carrier that is of higher frequency than symbol 1 representation. Now, when I come to the waveform, once again plot the x-axis, which is the time axis, then you divide the x-axis into 5 intervals, then you write down the data over each bit interval, and let us now start plotting the modulated signal. For the very first bit interval, we have a bit 1. So, you come back to the equation for symbol 1 and you see we have a signal represented by square root of 2 EB by TB cos 2 pi F1 t. Here we are supposed to note the frequency F1. Here I have plotted a carrier signal of 2 cycles for representing bit 1. Then when I move on to the second bit, which is bit 0, please note I need to now change the frequency of the carrier. As you can see here, I have changed the carrier signal frequency to a higher one. So, this is actually F2, which represents symbol 0, and this is F1. We have a phase continuity which must be noted. Please note, there is no phase change whenever there is a change in the input data from either bit 1 to 0 or 0 to 1. the phase will be kept constant. So, this technique is also sometimes called as continuous phase frequency shift keying technique. Please note, it is CPFSK. Right. So, what we have done here is, for bit 1 we transmitted a carrier of, let us say, frequency of 1, and for bit 0 we transmit another carrier with a different frequency. For this case it is a higher frequency, and this process when continued will enable you to plot the modulated signal waveform for the FSK. Right. That is about this numerical. If you like this video, kindly like and share this video and subscribe to my channel for more information on digital communication. Thank you for watching. Have a good day.